Spitsbergen. At mid-distance between Norway and the North Pole, it is an archipelago lost in the glacial Arctic Ocean. In these hostile regions, we lack much information enabling us to understand how their ecosystems function. Yet there is urgency. Global warming is happening so fast that Arctic ecosystems are in immediate danger. Their survival is estimated at between 25 and 50 years. It is in this alarming context that this expedition was undertaken, understanding this environment before it disappears. Jean-Michel Bichain is a biologist. He is also a teacher in a horticultural school in Alsace, and when organizing this expedition, he hoped to integrate 5 of his students. The team also has another teacher, a zoobiologist, as well as photographer. But before leaving Longyearbyen, they must yet complete their equipment. Spitsbergen is the main island of the Svalbard archipelago, and this territory is autonomous, even though linked administratively to Norway. Populated by only 2,000 inhabitants, Longyearbyen is the most northern capital of the planet. Former mining town, it is now the starting point of numerous expeditions to the pole, be they scientific or touristic. Jean-Michel and Camille came searching for an indispensable accessory. These rifles are obligatory in Svalbard because of polar bears. Last season, a tourist was killed in an attack. The boat will take them tomorrow. They are quite ready for the big departure. The team joins the study area by sea. The mission has 2 objectives. The first is scientific. Conduct a biodiversity inventory and search for the biological indications of global warming. The second objective is educational. Jean-Michel hopes to convey the skills and the taste for field inventory work to his young teammates.
We have a last-minute program change on the advice of the ship's second-in-command. Basically, he recommends a more wind-sheltered zone, better suited for our camp.
Jean-Michel, Camille and Marie-Lilith board the Zodiac. They hope to find a landing site suitable for the establishment of the base camp.
We'll look at 2 sites, in fact. We'll look at the site aimed for at first, Phantom Moden, which is the Phantom Cape. We'll see what the terrain is like, and then go a little more north to a second possible platform, and then we'll choose, well, now.
Once the docking site chosen, it will no longer be possible to carry the gear over long distances. So the most appropriate site must be chosen right away for spending the next 3 weeks.
Although there's a little distance, there's plenty of wood. Even if there's 200 meters to walk, it's okay.
While Jean-Michel looks for the rest of the team, Marie-Lilith immediately loads the rifle. After 3 round trips, everyone is on the beach.
Okay, we're all on the beach. Thank you very much. Have a good trip.
Thank you very much and have a good vacation.
Okay, see you in 2 weeks.
2 weeks, yeah.
Voilà, on est parti.
Well, here we go. At first glance, there's wood. Well, maybe we'll be able to warm up and prepare a fire. It seems that keeps away bears, but it will also allow us to heat water and eat. But otherwise, there's not much, actually.
Sinon, il n'y a pas grand-chose, effectivement.
We'll give it a go.
On va essayer.
Now the 750 kilos of equipment of the expedition must be moved. The strength of this mission is to bring on site, on the terrain, all the material necessary for a scientific study. Researchers generally find it difficult to work in these extreme places, especially with such logistics. Due to this, Svalbard is very poorly known with regards to biodiversity. Only 20% of the territory has been studied. Located in the Arctic Ocean, the Svalbard archipelago has a polar climate. The landscape bears the scars of this extreme climate. One sees primarily rock and ice. 60% of the territory is covered by glaciers. Life has only very little room to grow, and above all, it must confront here the terrible polar winter. At this latitude, the sun disappears completely for 5 months of the year. The polar night lasts from October to February, with temperatures reaching minus 40 degrees Celsius. Svalbard is then amassed in the Arctic ice flow. Even when the sun reappears, the rays have little impact and bring barely any heat. The thermometer passes above zero only during the months of June, July, and August. With such a short, favorable period and the ground frozen up to 100 meters deep, life prospers with difficulty here. The whole team sets off towards the first research station. Preparation for the expedition has taken all of their spare time for months. They will finally be able to start working. And for now, the weather is surprisingly favorable to fieldwork. After a few hours' hike, they reach the top of the glacier. While there are no plants or even earth to speak of, will they find life here?
We raise the pebbles at the edge of the snowbank. The temperature is just over 0 degrees, and yet I see a small columbola, so we've small fauna developing here.
Off we go to raise stones, and we see columbolas. The technique is to turn over stones, often those close to the water, watch, see if something moves, and once we see something, try to catch it with a wet brush and gently transfer it to this tube with alcohol.
Columbola are one of the rare organisms that survive in such conditions. They live at the foot of glaciers, in the mud and stones. To move in such an opaque environment, they have a long pair of antennae. Their body is covered with hooked hairs that allow them to trap air and have an oxygen reserve when immersed in the mud. Snow is also not an obstacle for them. Columbola, in fact, secrete an antifreeze protein that inhibits the formation of crystals of ice up to minus 6 degrees Celsius. Columbola survives the long winter by reducing its metabolism to the strict minimum. All vital functions are then reduced, but they can resume a normal life as soon as the temperatures become positive. These columbola have adapted to the extreme climate of Spitsbergen, but what can they possibly feed on?
We have here what is probably a very short ecosystem, consisting of very few links. Organic matter has therefore either been imported, by the wind for example, debris, or by movement of the glacier, etc., or eventually bacteria that produce organic matter from mineral water. And then these little creatures seize the opportunity and eat, and will eventually be eaten themselves by 1 or 2 species. We've seen spiders a bit lower down.
To escape predators, columbola have a secret weapon, a jumping organ placed under their abdomen. When it unravels, it allows them to leap more than 10 centimeters, which on our scale would correspond to a jump over the Eiffel Tower.
An extreme environment is above all a medium that's biologically poor, but poor in terms of number of species, because it's rich in that the species that are here are extremely well adapted and whose evolutionary history is unique and linked to these ecosystems.
If organisms are found at the edge of the glacier, can one find life in the glacier too? Yes, even ice is an ecosystem. These microscopic algae undergo photosynthesis. Thanks to the sun, they produce organic matter. This organic matter is the favorite meal of rotifers, strange animals that owe their names to the 2 crowns of cilia which surround the head and function like a wheel. They swirl in opposite directions to move nutrient particles towards their mouths. And here is the largest predator in this food chain, which measures not more than 1 millimeter, the tardigrade, which is also called bear cub of the water due to the funny way it moves. It doesn't swim, but uses its impressive claws to cling to fragments of plants, which gives this clumsy-looking motion. If tardigrades are found everywhere on the planet, it's certainly due to their amazing capacity to resist in extreme conditions. They survive toxic products, radiation, vacuum voids, and high pressures in an incredible way. In order to not freeze, they are able to empty 99% of their water and replace it in their cells by a sugar that they synthesize or take from algae they eat. Back to the camp. Jean-Michel shows us around.
And let's start simply with where we sleep, which can be considered our dormitory. A small detour by our weather station, and a weather station here is actually not anecdotal. I remind you, we take samples of flora and fauna, and it is always interesting to correlate weather information to our samples. And that's our base tent, that's split into multiple spaces. First is the common space where we hold meetings, eat if necessary. We'll start with the pharmacy, the medical center. I cross our common space again to arrive in front of a place that I like particularly, our field laboratory. Here Marie Lilith works on our database. So this is the framework of our expedition, our place of life and our place of work. And then I'd tend to say a place of beautiful discoveries, scientific discoveries. And then for most of us, enriching experiences, discovery of the field, discovery of biodiversity, of Arctic environments. And for some of us, especially among my students, I hope discovery of vocations on the environment and on biodiversity.
If glaciers can harbor microorganisms, they are too cold and too unstable for life to develop in a more visible manner. The majority of the species on Spitsbergen should therefore be found in the narrow but relatively stable band found between the glacier and the sea, the tundra. It is to this area that the team will now turn. But to access this study area, you have to cross this river of melted snow. The water is only a few degrees above zero, and the rocks are slippery. Some will not emerge safely from this crossing. Roland, the second teacher, has sprained his ankle. I slid on a stone and I fell in the water, and my ankle has slightly suffered.
Okay, we'll bandage it.
These small incidents do not prevent them from continuing their work, and they can start the inventory of the flora.
So I note the GPS coordinates of the station we're going to study. So we have latitude, longitude, altitude, and a short general description of the environment. And then we place our quadra and count the species there 8 times. We note soil quality, which means do we have gravel, sediments, etc., to get a general idea of the species present here. We started from the sea and will go towards the mountain, in fact. And we'll repeat this several times along the coast around our camp.
The goal is to better understand the ecology of these species, what milieu they prefer, where to find them in greater numbers, an amount of data that will be added to those already existing on other areas of the archipelago. In addition to combating the cold and the polar night, plants here have to fight a third enemy, the terrain.
If you look a little bit around us, we see that there are areas completely covered by vegetation, and then areas that are less or not at all, and this is linked to the stability of the soil.
The soils of the Svalbard are very unstable. Snow, avalanches, ever-changing streams move rocks incessantly. Plants need stability and thus have difficulty installing themselves perennially on such terrain. To survive, they must continuously recolonize their environment.
When we have a wind-sheltered place like this, where seed sediments accumulate, we immediately have vegetation settled there. Here typically is a pretty bed of dryas settling in. And the plants, once they're rooted in there, will try to colonize outside, like here with runners with creeping stems. So the goal is to hang on and go, win inches like that, bit by bit. Plants fix the soil, tend to stabilize it. So, if you're in an eroded area, you won't last long, but if you're near it, you'll contribute to stabilizing it. And then eventually have these stages of tundra here on a really stable, less dynamic soil in terms of erosion, with other plants that will come and add themselves, which will really build what is called the tundra.
In the tundra, plants that manage to settle in will have to, in addition, withstand extreme temperatures. In winter, they are protected by the snowpack, but that eventually withdraws, so these plants have special adaptations to the cold.
The leaves are reduced to decrease the surface with the atmosphere and the temperature. Typically, all the flowers that are here are very narrow, lanceolate leaves with a very small surface. This is one of the adaptations to the Arctic environment.
But some plants go further. This one is literally covered with hairs. These hairs are so tight that they trap air and play the role of thermal insulation, and they screen the harmful rays of the sun. Moreover, Spitsbergen plants are most often in the form of compact pads. How to explain such a phenomenon?
There are 2 explanations to this. This compact design offers good resistance to wind, but also cold. Equally, the plants will die and manufacture their own humus, their own organic matter for those who will come after. So in fact, they form a kind of soil on the surface via generations of plants that are going to die on this spot.
Here, the window of time during which plants can grow is very short, only 2 months to grow and reproduce before the frost returns. In addition to their ability to withstand the cold, organisms that live here are able to carry out their cycle in a very short time. Despite the scarcity of resources, it is finally a whole ecosystem that manages to survive here. Lichens, mosses, plants and insects manage to get the most out of these difficult conditions. Here, life makes the best of everything, as with these feces that house flies and mushrooms. This sum of these small species allows even a few large animals to live here, at the top of the food chain.
Here we see two reindeer, which are subspecies endemic to Svalbard. It is smaller than the classic reindeer, and overall there are species that are high on the general public sympathy list, the polar bear as well. But we forget that even though they look nice or endearing, they're only a really tiny part of the biodiversity. On Earth, there are about 5,000 species of mammals in the 1.7 million known species and 14 million suspected. So, when a mammal species is in danger, it's probably a dozen, 100 species of invertebrates that are in potential danger of extinction. We're looking here at rather small organisms. Invertebrates that live in mosses in the soil, under pebbles, the hidden part of biodiversity. But they're finally the most important, those that modify the soil, that act at the beginning of the food chain. They're the workers of the ecosystem. Biodiversity is not only the tiger, bear or panda. It's also things with less of a general sympathy reserve. It's worms, snails, it's tardigrades, in fact, everything you don't see. And it's the majority of the biodiversity.
For the moment, the weather is incredibly clement. It's unusual here, and heat records will also be beaten during these few days. As these temperatures are favorable to insects, the team installs a malaise trap near the camp.
The flying insects will not see this fine mesh. Here, look, one's already on here. If they're caught on this part in the middle of the tent, they'll want to climb. It's really a reflex. They climb and get to the roof level here. And here there's only one exit possible, into a tube, where we've put alcohol. We leave the trap, take the sample-filled tube, and look at all we've trapped in this insect trap tent.
With these temperatures, it looks a bit like a holiday camp. But one must not forget that the risks are always present. Team members take watch duty in twos. In this season of meager resources, polar bears may be attracted to the smell of food coming from the camp. Best to guard against dangerous encounters, even when relieving oneself.
What on earth is this?
It also happens that one falls on something totally unknown.
Honnêtement, j'en sais rien du tout.
Honestly, I don't know.
Je vais pas dire de bêtises, là, c'est...
In places, it makes me think of a bacterial film.
Je te dis, un film bactérien. Bah là, pour le coup, je vais faire une petite photo.
I'll take a photo, and then I'll show it to some microbiologists. Maybe they'll have an idea.
Qu'ils ont une idée.
Or algologists.
ça décompose la matière, quoi, aussi. Hein,
It decomposes matter into a bacterial film. It recycles. At the same time, it can be used as food for a number of microorganisms. So it's a link in the food webs.
C'est un chaînon à part entière des réseaux trophiques, des réseaux alimentaires.
It transforms matter, either mineral matter into organic matter or vice versa, organic to mineral. They're very important links.
The wind has set in and temperatures have really dropped. The luckiest work in the tent, but people are always needed outside to heat water, mount the watch, or collect wood. Even if there is no forest or trees on Spitsbergen, wood is strangely an easy resource. It can be found in abundance on the beach.
There's a bit of everything, it seems. Driftwood, perhaps, wood from different shacks. Habitats and mining towns all around the Svalbard. And it seems that currents come all the way from the Barents Sea, bringing wood from Siberia. Quite a distance.
This wood ensures at least one hot meal during the day. Even if the team seems to have exhausted the myriad ways to cook salami, the meal is perhaps the only moment where one forgets fatigue and the cold.
Enjoy it.
Enjoy, everyone. Thanks.
It's 7.4 degrees in the tent. It's not bad, eh?
As soon as the weather becomes a bit milder, the team temporarily splits in half to cover more ground. Jean-Michel, Marie-Lilith and Aurélien go study another area, a day's walk from base camp.
So, we prepare a 3-day camp in autonomy, with our gear and 3 days' rations, and one tent. The rest of the team remains at base camp, and will take samples a bit more to the north. We hope to reach Camp 2 this evening. Off we go. In 3 days, then.
After 7 hours walking along the fjord, they decide to set up camp at the entrance of the Gipsdalen Valley. They hope to find slightly different biotopes here. The Gipsdalen Valley is several kilometers long and a kilometer wide. Originating from a glacier, it is a huge catchment that collects all the meltwater. This area is therefore completely flooded in early summer and then dries slowly. One more constraint for the organisms that live here. The scientists will therefore focus on these wet habitats.
Here's a soil sample done here. We'll dry it later to see what fauna we can find.
Pour voir la faune qu'on peut retrouver dedans.
With all these stagnant waters, mosquitoes abound. As soon as a ray of sun pierces, they attack. But scientists resist. Marie-Lilith seizes the opportunity to set up insect traps.
We dig a small hole in the ground, lay a trap like that, filled with alcohol. The insects will simply fall into it. And we'll put out a line of them from here down to behind there to see what kind of diversity we find here.
Marie-Lilith repeats the process several times in order to have an overview of the biodiversity in this area. Jean-Michel uses another type of trap. Certain insects are attracted by bright colors, notably pollinating insects that get caught in the mixture of water and dishwashing liquid. But it's chiefly the presence of numerous streams that drew Jean-Michel to this valley.
Ouais, on va mettre un petit filet.
We'll put a small net in, a drift net. In any case, it will be microfauna as usual. The idea is to put the net this way for a few hours in the current, and then we'll see what there's in there.
Despite its temperature of only a few degrees, the waters of the lakes and rivers of the Spitsbergen are full of life. Daphnia are small crustaceans that feed on microalgae. They filter several thousand per hour, which prevents the latter from asphyxiating the aquatic environment. Thus, direct light, so rare to Spitsbergen, penetrates more easily under the water, favoring the growth of other organisms, such as copepods. But how do all of these organisms survive in water that is frozen most of the year? When conditions deteriorate, Daphnia and copepods produce more solid eggs to ensure their survival. The membrane of these eggs is able to withstand pressure and freezing. The eggs will fall off their mother's body and fall to the bottom, waiting for more favorable conditions to hatch.
Ah, copepods. So there's one. It's the first crustaceans I've seen in this Svalbard. In any case, in the field. And that's really wonderful. Here, there's another one. Superb.
Back at base camp, the team sorts samples in the small field laboratory. Spitsbergen is poorly known, with very few samples. For this expedition, scientists voluntarily brought equipment to study all types of species. Even if it means heavy logistics at the start, this material allows them to be as comprehensive as possible. Getting here is difficult, best be thorough.
Eliminate the big fragments, and then use a dropper, and with a brush, so you make a pile with the fragments, a pile with the specimens, and you'll recuperate the specimens with the dropper.
But this is only a first categorization. Once back in France, it will take hours to process samples. This work will be added to an inventory of life in the area and possibly reveal new species. These results are all the more important that the area may experience major upheavals.
It seems that the warning flags are up on global warming. And certain projections indicate that the first ecosystems to be affected in the future are the Arctic and polar ecosystems. They believe Arctic areas will have double the average warming of the rest of the world.
On va avoir le double du réchauffement moyen dans les zones arctiques sur l'ensemble de la planète.
Therefore, a 1 degree increase in a century means 2 degrees in the polar environment. And as these animals or flowers are adapted to a very specific and cold environment, these changes will be very important.
Ces changements-là sont quand même importants.
The Arctic is in a state of emergency that makes this kind of expedition necessary. It's an ensemble of specific ecosystems that could disappear before even having been fully studied and understood. The team enters the final days of the expedition. The beauty of the area no longer allows them to forget the fatigue, the total absence of night, guard duty, the cold, the wind. All of this proves exhausting. Plus, a new hike awaits them today. The objective is the foot of the glacier, which is at the end of the fjord. To protect themselves from the wind, the researchers find refuge in old shacks. If Spitsbergen is sparsely populated, it is a land rich in history. The first to come, as of the 17th century, were certainly trappers and fishermen. When coal was found came the miners. Always open to the few passers-by, these shacks bear witness to the harsh living conditions of the time.
This is our last station on Bunzlo land, and we finish nicely with the North Glacier bordering Billefjord. It's a huge glacier. We know the Svalbard glaciers cover 60% of the land, and what interested us today was to see if indeed there is, as at the other stations, life. At the foot of this giant reigns a freezing cold. What are the consequences on the surrounding life? We've north wind coming off the glacier. I don't know its length, but it has to be several tens of kilometers. The wind is extremely cold. You can feel it. It's much colder than at the camp, 10 kilometers further down. And so this whole area remains in a relatively stable climate, which is not the case in the coastal areas at the bottom of the fjord. So, even though it may seem very cold for the fauna, it's easier to go from -12 to +1 degrees centigrade than from -12 to +15 centigrade. The glacier therefore acts as a huge refrigerator. If it maintains a cold climate that bothers most organisms, it also limits temperature variations. We can see that the glacier is active. It's quite surprising. A wave caused by a falling serac, but it's the season. It lives, it growls. It's impressive. For several years, the glacier melt has increased. Average temperatures increase and the rains are more and more frequent during the summer. Polar organisms are completely dependent on the layer of snow and ice that forms during the winter period. The disappearance of this layer of ice or snow could deeply disrupt, even bring on a mass extinction of polar species. With the absence of this insulating layer that protects against extreme temperatures, but also due to runoff effect and greater erosion. Finally, global warming can totally upset the balance that prevails in these polar environments and eliminate organisms that, due to their adaptation, cannot live elsewhere but in these Arctic conditions.
It's cold. We're ready to go back now.
Bitten by the cold wind coming down from the glacier, the team pack their gear before starting back.
Here I've two little things, and there.
I have small columbola, and in that one I believe that there is a tiny little red mite.
Oh, great. We didn't have those. I think we didn't.
Only several miles from the glacier does the temperature get milder. But on the way, the team will make a macabre discovery. Jean-Michel immediately seeks any parasites in the plumage of the animal.
Un goéland boréal.
A boreal seagull.
Cadavre qui est
Not an old cadaver, probably from the colonies we see at the top of the cliff, where there are hundreds or even thousands of birds of different species.
voire milliers d'oiseaux de différentes espèces. Alors c'est complètement
So it's completely inaccessible to us. It's really steep, rocky cliffs.
Donc il y a aucune possibilité qu'on
There's no way to observe them more closely other than by trapping, or unfortunately, by the animal corpses found on the shores.
par les cadavres qu'on trouve sur la grève.
Even if he did not come to study vertebrae, Jean-Michel still takes a genetic sample. The presence of marine birds on Spitsbergen is not surprising. If the terrestrial fauna is relatively poor because of the polar climate, the marine ecosystem is very rich. The Svalbard archipelago bathes in the Arctic Ocean, which is characterized by its very cold waters and the presence of an ice floe. As water temperatures reach only a few degrees, it is denser and more nutrient-rich. This promotes plankton, an ensemble of billions of animal and plant organisms. Plankton is the base of the food chain. There is equally krill, a kind of small shrimp that lives in vast swarms attaining up to 2 million tons over 450 square kilometers. In addition to seals and whales, the Arctic Ocean is the territory of the beluga. Also known as white whale, this animal has a sonar that allows it to navigate in the ice channels that form a labyrinth under the ice floe. It is also capable of detecting areas where the ice is thinner to break through it in order to breathe. The beluga can hold its breath 20 minutes if necessary. Belugas are sociable animals. They live in small groups and sometimes regroup by the thousands in the estuaries. They are very communicative amongst themselves, using a wide range of whistles and clicking. The population is dispersed all around the Arctic Ocean. Scientists estimate that only 100,000 individuals remain. After a 21-day expedition, it's time to pack up. There is no doubt that the students will have unforgettable memories of the 3 weeks spent in the Arctic. With regards to the scientific assessment, it will take a few months before it can be truly done.
Petite boîte avec une
A small box with 100 samples,
9 personnes,
9 people
21 jours,
for 21 days,
qui va occuper à mon avis
which will be, in my opinion, a good year's work for the whole team and the researchers linked to the project.
l'équipe et des chercheurs liés au projet.
But just before leaving, Jean-Michel wishes to explore an area that he spotted from the shore.
Regarde là.
Look there. You have areas of scree at the base of the pillar areas.
T'as vraiment des
You have an area of green platforms.
The slope is steeper and steeper and the climb more and more difficult and dangerous. The scree is not stable and rockfalls are common.
Biodiversity remains a science where it is first and foremost the field. So, necessarily, that sometimes means engaging oneself, as we're doing now.
S'engager, comme on est en train de le faire maintenant.
Finally, they reach the foot of the cliffs.
Eh ben c'est inattendu.
Well, this is unexpected. Really unexpected.
Une zone
We've a very vegetated area.
végétalisée vraiment importante. On a une grande diversité de
With a
plantes.
wide variety of plants.
Un sol,
Soil,
un sol. Ouais. Mousse,
moss, lichens,
lichen. Puis là on a des renoncules,
and then there are ranunculus, saxifrage, even brassicaceae, plants in the cabbage family.
et ce sur une surface.
And on all of this surface that we saw from below.
Ici des plantes qui sont en fruits.
Here we have plants that are in fruit or in flower, while below this one was not found in flower.
En bas. Et cette
And this ranunculus had not at all been found before in the tundra.
dans la toundra.
From the valley, they did not expect to find such diversity grouped on such a few hectometers. Jean-Michel and Aurélien have only a few hours before the rendezvous with the boat. They immediately engage in an inventory of the flora. As they predicted, the results are surprising.
On a trouvé sur ce seul
We found on this single slope half of all that we've seen to date in 10 days of observation on the tundra.
But then what are the reasons for such diversity? The explanation is simple. These lawns are located just below a seabird colony. Their guano brings nitrogen matter. Fertilizer literally falls from the sky. In the very mineral landscape on Spitsbergen, the infusion of organic matter is a blessing. Mosses, lichens, and other plants benefit from it. Little by little, these organisms stabilize the environment that becomes more sustainable each year. Contrary to what one might think, there is thus a strong link between the marine environment, very rich, and the ecosystem, relatively poor.
Donc ça valait le coup un petit peu de.
So it's a bit worth taking a few risks in the scree, because we would have missed this.
On serait passé à côté de ça.
And I think this is rather symbolic of studies on biodiversity. We often see things from afar. We think we know our environment, while overall, we know only 10% of global biodiversity.
While waiting for the boat, Jean-Michel catches up on lost sleep. This time, the study is well finished. In a few hours, everyone will finally find a little comfort, hot showers and hot meals. The territory that they leave behind them readies for yet another winter. While the sun declines every day a little more, its inhabitants, small or large, are already preparing to face the night and the cold. The summers are short on Spitsbergen. May they remain so.